Hey everyone, and welcome. So, if you've ever dipped your toes into the world of blockchain or Web3, you know it can feel like you're trying to learn a completely new language, right? You hear all these wild terms like proof of stake, dApps, and rug pulls just flying around. Well, today we're going to be your translator. We're going to break it all down, make it simple, and help you finally make sense of it all. So, here's how we're going to do it. We're going to build this thing from the ground up, block by block. First, we'll look at the absolute foundation, the digital ledger itself. Then, we'll get into the rules of the road, how everyone agrees on things. After that, we'll talk about the digital stuff you can actually own, what you can do with it, and finally, we'll get real about some of the challenges in this new world. All right, you ready? Let's get into it. All right, section 1, the foundation. You got to understand that everything we're about to talk about is built on this totally new, kind of revolutionary way of keeping records. So, what exactly is this new beast of a database? At the very heart of it all is the blockchain. The easiest way to picture it is just a digital record book that isn't owned by any one person or company. Instead, a copy is shared with everyone on the network, and they all work together to verify it. Now, if you want to sound super smart at your next dinner party, you can call it an append-only, cryptographically linked ledger. All that really means is you can only add new entries, you can never change the past, and the whole thing is locked down with some seriously heavy-duty math. And this is where it gets really mind-bending, especially when you compare it to what we're all used to. Think about a normal database, like the one your bank uses. It's centralized. The bank has all the control. They decide who gets to see what, and, this is the big one, they can edit the data. A blockchain just flips that whole model on its head. Control is spread out among all the users. It's decentralized. The data is usually public for anyone to see and verify. And the records are immutable, meaning once they're in, they are set in stone, forever. So that leads to a huge question, right? If there's no boss, no one in charge, how in the world does everybody agree on what's true? This is probably one of the most brilliant parts of the whole system, and it's all about creating trust without needing a middleman. Well, the answer is something called a consensus mechanism. Honestly, just think of it as the official rulebook for the entire network. It's the system that all the computers or nodes follow to agree on which transactions are legit, which keeps everyone's copy of the ledger perfectly in sync. Now, there are two main rulebooks out there, and they really represent two totally different philosophies on how to keep the network secure. First up, you've got proof of work, which is the original system that Bitcoin uses. Its whole idea is that security comes from raw computer power, pure digital muscle. Miners use a ton of energy to solve complex problems, which makes the network super secure. But wow, does it use a lot of electricity. On the other side, you've got proof of stake, which is what networks like Ethereum use now. Its philosophy is different. It says security should come from having skin in the game. Users lock up their own money as collateral. If they play by the rules, they get a reward. If they cheat, they lose their money. And the craziest part, this approach uses over 99% less energy. The difference is just staggering. So what exactly is this mining thing we always hear about with proof of work? Let's break it down real simple. First, a bunch of recent transactions get bundled together into a block. Then, thousands of miners fire up their computers to basically play a high-speed guessing game. They're trying to find a specific secret number called a nonce. Think of it as finding the one winning lottery number out of trillions. And third, the very first miner to guess that correct number gets to add the new block to the chain, and for all that work, they earn a reward. But what if the rulebook itself needs an update? That's where forks come in. A soft fork is kind of like a software update on your phone. It's backward compatible, so even if you don't update right away, things still pretty much work. A hard fork, though, that's a whole different story. It's a major change that isn't compatible with the old rules. It's like a literal fork in the road. It splits the chain in two permanently, and everyone on the network has to pick a side. Okay, so that's the pipes and the plumbing of how this stuff works. Let's move on to the fun part in section 3, the assets. Now we get to talk about the stuff people actually own and control on these networks. And it all boils down to one critical phrase: your keys, your crypto. Listen up, because this might be the single most important thing to understand. You get two keys. Your public key is like your email address or your home address. You can give it to anyone, and it's how they send you stuff. But your private key, that's your password. It's your signature. It's the secret that proves you own everything and gives you the power to spend it. I'm going to say it again. You never, ever, ever share your private key with anyone. So where do you keep these all-important keys? In a wallet. And here's something that really trips people up at first. Wallets don't actually hold your coins. Your coins always live on the blockchain itself. A wallet just holds the keys that unlock them. A hot wallet is connected to the internet, like an app on your phone. It's great for quick, everyday transactions. A cold wallet, on the other hand, is completely offline, like a little USB device you keep in a safe. It's the absolute best for secure, long-term storage. Now, you might hear the words coin and token thrown around like they're the same thing, but there's a key difference. Native coins, like Bitcoin or Ether, are the built-in currency of a blockchain. They're the lifeblood, the fuel that pays for transactions and keeps the whole network running. Crypto tokens are different. They're assets that are built on top of an existing blockchain, and they can represent almost anything you can imagine, from a membership pass to a vote in a project. And as you can see here, the universe of what you can own is getting pretty diverse. It's not just coins and tokens. You have NFTs, non-fungible tokens, which are totally unique, one-of-a-kind digital items like a piece of art or a concert ticket. And you also have stablecoins, which are a type of token designed to hold a steady value, usually $1, which makes them super useful for things like trading or saving. Okay, section 4, the action. We've got the foundation, we've got the rules, we've got the assets, but what's the point? What can you actually do with all this stuff? This is where we go from theory to real-world application. The secret ingredient that makes it all happen is the smart contract. The simplest way to think of it is as self-enforcing code. It's a program that lives on the blockchain, and it automatically runs when certain conditions are met. It's like a super-powered vending machine. If you put in the right amount of money, it's guaranteed to give you the snack. No cashier needed. The code is the law. This is the engine that truly makes Web3 possible. And what does this magic code unlock? Well, a whole new universe of possibilities. It lets us build dApps, or decentralized apps, that aren't controlled by a single company. They're the power behind DeFi, or decentralized finance. They make things called DAOs possible. Think of them as online communities owned and run by their members. And they can even use things called oracles, which are like secure bridges that feed real-world information, like sports scores or stock prices, into the blockchain. Let's just zoom in on DeFi for a second, because it's such a perfect example of this in action. The entire ambitious goal of DeFi is to rebuild our financial system, loans, trading, saving, but using smart contracts instead of banks and brokers. The idea is to cut out the middlemen and create a system that's more open, transparent, and accessible to anyone, anywhere. And that brings us to our final section, the realities. Because for all this amazing, world-changing potential, we have to be honest. This technology is still super new, and it comes with some very real challenges, costs, and risks that you absolutely have to know about. If you've ever tried using a blockchain, one of the first things you probably noticed is this. Why on earth is this so slow sometimes? And why does it cost so much money just to do something simple? It's a really common and totally valid question. The short answer is gas fees. See, every single action on a blockchain takes computer power, and that power isn't free. Think of it like a highway. The gas fee is the toll you have to pay to use the road. When it's rush hour and everyone wants to use the highway at the same time, the tolls go way, way up. It's a system of supply and demand, plain and simple. But don't worry, some of the smartest people in the world are working on a solution, layer 2s. Sticking with our highway analogy, think of the main blockchain, that's layer 1, as this big, super secure highway that can get really congested. A layer 2 is like building a brand new express lane on top of it. It takes a whole bunch of cars, or transactions, bundles them together, processes them super fast and cheap in the express lane, and then merges the final result back onto the main highway. This is a total game changer for making this technology actually usable for everyone. Okay, now for a really important warning. A rug pull is one of the nastiest and most common scams out there. Here's how it works. A team creates a new project, they hype it up, they get tons of people to invest their money, and then one day, they just disappear. They drain all the money out of the project and vanish, literally pulling the rug out from under their investors, leaving them with completely worthless tokens. You have to be so careful. So we've talked about the complexity, the sometimes crazy costs, and some very real risks, which leads us to the final question. With all of that baggage, why are so many people so excited about this technology? I think the answer really comes down to its core promise, the chance to build a more transparent digital world, one that doesn't rely so much on powerful middlemen, and where we, the users, have actual ownership and control over our digital lives. Now, whether we can actually deliver on that massive promise, well, that's still the big question, and it's what makes this space so fascinating to watch.